Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on an introduction to Trellix Network Forensics. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix Technical Support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our first presenter today is Shiraz Khan. Shiraz is a senior technical instructional designer with Trellix. Shiraz has been with Trellix since 2014. He develops analyst and admin training for network forensics, security orchestration, and interrelated products and services. Our second presenter today is Nasir Shakur. Nasir is a solutions architect for Trellix, specializing in network forensics and email security. Nasir has over 20 years of experience working with technology companies in the San Francisco Bay Area and Silicon Valley. Ladies and gentlemen, Shiraz and Nasir.
Hey, thank you, Nick, for the intro. Hello, everyone. Without any further ado, let's go over what is planned for today's webinar. We're going to talk about what is network forensics in general as a definition, and then move on to describe the network traffic of the network forensic solution from Trellix. We will look at some common deployments of both of these appliances, and then how these appliances integrate with other Trellix solutions and appliances. And we'll complete our webinar with a demo followed by a Q&A session. Network forensics, as a definition, is a science and a set of tools to analyze or investigate criminal activity on the network that help establish facts and evidence used in a court of law. Who are the ones who primarily use this tool? It's incident responders, analysts and investigators investigating perhaps a breach. And then cyber threat hunting is the proactive hunt for cyber attacks that have not yet breached or have breached but are not yet discovered. As far as the science is concerned, network forensics analysts must be familiar with the following, among other computer sciences: networking models such as the OSI and TCP/IP model, critical application protocols, common attacks on these protocols, the network environment in which they are working, alerts from integrated systems, and threat hunting techniques, among other techniques as well. What basic functionality does network forensics tools provide? They should be able to capture full packet data, allow for search and filtering of network flow traffic, provide visibility across various layers of the traffic, and then automatically analyzing the packet data to produce further metadata that may be of use. Visualize patterns and anomalies in the network flow, aggregate network traffic for easier comprehension, and then reconstructing network artifacts from the full packet capture data. Moving on to the aspect of network activity. What sort of network activity are we looking towards collecting to be able to perform an investigation or to perform our threat hunt? The first one that comes to mind is the full packet capture data, the PCAP data. This from the PCAP data is derived network metadata. This network metadata comes from all of the different layers of the from various layers of the TCP/IP model, but it also can be a result of data that has been analyzed. So, for instance, there is a technique called network deep packet inspection. It is utilized by Trellix Packet Capture. It's a mechanism to use to parse the packet header and the payload to identify the actual application protocol in use. Because we all know that we cannot just use a port to identify what kind of traffic it is. This is an example of some intelligence that's included in the packet capture engine. The other data that we're interested in is the payload data that's again is derived from the packet capture, but is typically reconstructed in a manner so that we can derive files, artifacts, and then study whether that file is malware or not. Other areas that one can look at is IDS and IPS systems for alerts, endpoint system logs, routers, firewall, proxy logs, and so forth. All of this data is the network activity that we are interested in. As far as the network traffic forensics appliances, you can see two different appliances, the packet capture and the investigation analysis appliance. The packet capture is it's deployed as a very high performance, highly advanced intelligent packet capture device and a sensor that can be deployed in more than one location and managed by the investigation analysis system. As far as the packet capture, it captures the full packet capture data very fast. It allows for searching within the TCP/IP layers, not the OSI, the TCP/IP layers 1 through 3, and then also includes the capability to add suricata rules that if there is traffic that matches any of the rules that an alert would be thrown, guiding you to that particular part of traffic that you're looking for, that you would be interested in investigating. It includes a web UI with a very fast search and a REST API. But typically, the analysts typically use investigation analysis web UI to perform the analysis because it's a lot more powerful in terms and fast in terms of looking for and drilling down very quickly to the area that you are looking in your investigation. So what it allows for is to search across, and this is the power of investigation analysis, is that it allows you to search across one or more packet capture appliances that may be connected to an investigation analysis system, and then it also allows you to perform your searches across layers 1 through 4, including the application layer. It can extract flows with associated metadata. It can visualize the traffic. It allows you to reconstruct and merge PCAP data. You can aggregate alerts from the integrations and then also integrate with threat alert systems, for example, Mandiant's threat intelligence, and it can ingest STIX and OpenIOC format IOCs. The investigation analysis system will generate an alert if network traffic matches any stored IOCs. And again, both systems support a REST API. In this deployment, network diagram, packet capture is placed. So we're going to first look at packet capture, and then we will look at deployments in the investigation analysis system. In this deployment, it's placed at the network core, behind the network core firewall. And it records all incoming and outgoing traffic on the network among endpoints. Traffic is also recorded between the endpoints and your private network, for instance, your file servers, web servers, and so forth, your file servers and internal servers. And then it also will record traffic between the internal network and the public DMZ, where external servers such as web, mail, FTP servers, and so forth reside. These may be recorded, and the traffic recorded would depend on the level of security at the core firewall. If the packet capture is placed here, anything that's filtered on the core firewall would not be recorded on this packet capture. So the packet capture appliance will either take a feed from a span port on a switch, or take one from a TAP device, a TAP device that splits the traffic. So this is a typical simple installation at the network core. In this case, another type of deployment of packet capture may be at the ingress and egress point between the edge firewall and the core firewall. This achieves total visibility of the network, including endpoints, the DMZ, and the data center private network. Since no hygiene is being performed on external traffic at this location, at the egress-ingress point, it is important to filter traffic for adequate storage, including how often data will be purged on the packet capture appliance. Okay. This is an overview of two network forensics appliances in the network and connected to a single investigation analysis appliance. The investigation analysis can pull metadata from both packet capture systems. It can also manage these connected systems to apply software updates, Suricata rules, and in general, view the health status of these systems. Investigation analysis deployment options are either standalone appliance, that is the setup that we will be using in our demo today, or a multi-box cluster, and lastly, a distributed search deployment. Let's go over each one of these. In the IA or investigation analysis stand-alone deployment, this is a single box represented by the dotted lines, if you can see in the screen. And it contains every single standalone investigation analysis system is a single box cluster. It contains two internal data nodes. Okay, so one is called a master data node, and then the second one is just called a data node. And the master data node would be connected to one or more packet capture systems. In this case, we have two packet capture systems on a subnet 10.0240 and 10.0250, and these both systems are managed, and the load is it's managed and queried by the investigation analysis system for metadata from these two connected packet capture systems. So the way it works is, in this deployment, the IA, or the investigation analysis, acts as a standalone cluster without any other external investigation analysis appliance as part of the cluster, just a standalone. The master data node collects metadata from connected packet capture systems, evenly distributes data load between it and the other data node. Now, both data nodes store metadata and allow the metadata to be searched. This is the default behavior of a standalone investigation analysis system. The next multi-box cluster deployment involves more than one investigation analysis system. So in this case, a single investigation analysis system, in this case IA01, is configured as a master node with a data node, just like a standalone system, while additional investigation analysis appliances act as data nodes only in a multi-box cluster. Okay. So in this configuration, the other investigation analysis appliances that make up the multi-box cluster can only contain data nodes, and that are used to store and search metadata. That's it. They do not have the functionality of managing these other IA systems and packet capture systems and distributing the load between the other systems. They simply are storing metadata and allowing it to be accessible. The master node takes care of everything else. So what this does for you is that it will significantly increase the storage and search capacity of your investigation analysis appliances. In a distributed search deployment, this is an example. If you look at the bottom part of the screen, IASFO, represents one master. It represents the multi-box cluster that we just covered on the previous slide, where you have one or more investigation analysis system. In this case, the first one is the master node, master data node. The second one is the data node only, and it is managing the and processing data from the multiple packet capture systems that are in that particular network. So in San Francisco, you have a multi-box cluster of IA systems. And then you have additional boxes, one at different geographic locations. One is in Dubai, and the second one in Cape Town, South Africa. As far as the example of the so that's the outlet setup. But in order to manage all of the different IA systems and to have an overview and to be able to access packet capture systems on the entire network, we introduce the concept of a director node. So the director node, shown as IA Dallas, is a centrally located investigation analysis system that is either converted from a single box investigation analysis or set up as such. This deployment, again, is called a director node deployment, allows searching for metadata across all investigation analysis systems and associated packet capture systems or designated systems only. For example, IA Dubai, IA Cape Town, and IA San Francisco all are managed by this central investigation analysis system and has visibility over all of them. In this case, the director node does not collect or store metadata. All of this processing is done by the IA systems that are connected to it. It can pull packet capture data from or pivot to any connected packet capture system. And again, these systems, we assume that they also have their own packet capture systems connected to them, but not showed in the slide. An analyst on any investigation analysis data node could also gain permitted access to the director node interface, the web UI, from their own respective locations. In terms of how this traffic is secured and managed and transported, OpenVPN is used for secure communication over the web between the investigation analysis systems, right? As shown by the red arrows, the red dotted arrows. rsync, on the other hand, is used for transferring metadata and packet capture data from the packet capture systems to the connected IA system over using SSH for security. Director nodes can centrally deploy. Not only can they have visibility, but they can also deploy software updates, and they can also manage Suricata rules or deploy Suricata rules to any of the connected packet capture systems. They can also manage the software updates to the connected investigation analysis systems. Okay. Next, the network forensics integrations. So when we talk about network forensic systems, we're talking about both packet capture systems and investigation analysis systems. So for this deployment, in terms of network forensics, the investigation analysis web UI has, and the system itself is a centrally located system among all of these. And it is pulling data from these different systems to allow an analyst to perform the investigations with one pane, okay, without having the need to pivot as much as one would typically do if they were not integrated. So you can pivot from a network security system to a packet capture system. So for instance, if you were working on a Trellix network security, you find an alert, you can pivot over to the packet capture and pull a packet capture and look at the flow and traffic on using the web UI on the packet capture system. But typically, like I said again, investigation analysis web UI is the main analysis tool for anybody performing network traffic analysis and investigations. As you pivot from a flow in investigation analysis, okay, so you can also pivot from IA to packet capture. So you may be interested in a particular flow and you would want to look at further deeper level traffic. You can pivot to the packet capture appliance from the investigation analysis appliance. Next, investigation analysis integrates with packet capture, central management system, network security, email security appliances, and you are able and endpoint security, and you're able to pull alerts either from them directly to the investigation analysis system, depends on how you configure it, or if you connect to the central management system which manages these, you can pull the alerts of network security, email security, and endpoint security to the investigation analysis appliance. This is displayed in a pane called the alerts page in the web UI that you will see in our demonstration today. Next, malware analysis. So suppose you found you're investigating a flow and you pulled a PCAP or you reconstruct the traffic from within network investigation analysis web UI, and you have a few suspicious files that you want to submit for malware analysis. Trellix malware analysis does just that. However, when integrated with investigation analysis, you after you have reconstructed that file or the artifact, you can submit it to malware analysis and then get the malware analysis results within the web UI, again from the single pane, on whether that was malicious or not. And then you can also pivot from investigation analysis to the malware analysis environment from within the web UI. Threat intelligence, investigation analysis, and packet capture, both of these systems integrate with Mandiant threat intelligence and can automatically download indicators of compromise to search index metadata and identify threat matches. A Mandiant threat intelligence license is required for this integration. You can also integrate with STIX format. You can pull from STIX format feeds, pull IOCs, as well as I mentioned earlier, the open IOC format feeds. Once you pull those IOCs, if there's a match in the traffic, you would be able to see it within the alerts interface of the investigation analysis web UI. Both packet capture and investigation analysis can be configured to generate can be configured to pull license information from the DTI network based on activation codes that you apply to these systems and update these systems as a result perform software updates. Endpoint security, which is the Trellix endpoint security, also called HX, integrates with investigation analysis in that if you find a flow that you're interested in, and if there's a particular endpoint and you want to enrich the flow data that you have with metadata from the endpoint security system, HX. You can pull, for instance, you can pull the source IP address. You can pull the name of the host and the user that is using that particular endpoint. So that gives a little context as to who is working with that particular flow that you're investigating. The packet capture appliance can send L7 metadata and syslog data to Trellix Helix. So that could be used within the Helix console to perform your network forensics if the Helix system is used as a for your network forensics analysis. And then lastly, as we know, investigation analysis already has to be paired with a packet capture system for you to be able to pull PCAP files, and also for you to be able to query L7 metadata. That's what we've understood so far. But in the absence, for instance, you may not have a packet capture system. You're interested in intelligence investigation analysis, and you can pull L7 metadata from a connected network security system. Or you may just have a network security system in a particular part of the network where you may not have packet capture deployed. You can configure it to pull L7 metadata both from the network security system and the packet capture system for PCAP data. And that concludes the presentation part. I will now move on to the demonstration of an introduction to the Trellix investigation analysis tool. Let's move on to that section. In this part of the webinar, I'm going to present a quick overview of some sections of the investigation analysis web UI. This is the primary analysis/investigations tool in the network forensics solution. The second part of the demonstration is a simple hunting scenario where we will find malicious executables crossing the wire. This is the case where there's no alerting device present or connected with the investigation analysis appliance. This demo is not on the full features of the investigation analysis tool. Rather, it's a contextual demonstration within the objectives mentioned. I want to log into the system and start with just a simple intro to the dashboard and the web UI in general. We start on the dashboards page, and this lists several dashboards that are part of the pre-installed investigation analysis system. The only exception here is NTA2. This dashboard is used in our classrooms, and it is a custom dashboard. So you can easily create your own custom dashboard as well. For the purposes of this demo, I'm just going to go over the summary dashboard for now. And here, the summary dashboard comes with two different panels. One is the protocol overview panel, and then the second one is the event table panel. Protocol overview lists the kind of traffic that is crossing your network, and you can start filtering, checking and unchecking the type of traffic so you can view it in different visualizations as to what kind of traffic is on the network. And the event table, on the other hand, is the most widely used table, and this represents the results of the search that was performed. Talking about searching, if I were to simply just do a search and put nothing in the search bar, it'll come back with all of the events for the past 5 minutes. I can look at the time picker by clicking in this area and choose, let's say I want to go for the last 12 hours and see what traffic comes back. Again, there is no information in terms of what metadata I'm searching for, if I'm looking for an IP address or if I'm looking for a URL, whatever. None of that is specified. This is just giving me all of the traffic that is returned during that particular time period. And you can see the number of records are quite large. The purpose of investigation analysis is to start with a wider data set and then start drilling down quickly based on what you're looking for. You can do this in two kinds of situations. One, an incident response where you may have an alert. In that case, you would start in the alerts tab, and in the alerts tab, you can start drilling down based on the kind of alerts that you are getting. There's a lot of alert information here. In this demo, we're not covering alerts. We are covering the hunting scenario where you're actually just starting out with a large data set, and you need to find what you're looking for based on a particular hypothesis. But before we get into the hunting scenario, I want to show you a little bit of this dashboard and some of the panels in there. Here is a pie chart panel. When I hover over this, it'll show you the different kinds of analyzed application events that have crossed the network. You can see the largest number is DNS, maybe SSL traffic, and followed by unknown traffic, and then HTTP. This is typical traffic. And I can click on any one of these, add a filter, which appears in the left pane, and then just apply that filter. So as you can see, the term is basically the metadata that we are searching on, or we are filtering on, and the value that we are using is HTTP in this case. So this will return only HTTP events that are part of a smaller subset. Now, I'm going to look at, for instance, we are interested in a list table. So a list table, let's see what's in there. It is something that we've given it a name, destination IPs, and I've chosen the destination IP address field. I only want to see an aggregated list, which gives me the count of each IP address, destination IP address. I want to put it in descending order, and I want to see 10 rows. I can go up to 50 rows on this. And this is how we configured it. And you can see there's 10 rows. If I were to filter further, I could click on this, and it adds the filter in the left side and apply. So very quickly, I can jump down to a particular destination IP address and then start looking at the data that's associated with the destination IP address, what source IP addresses communicated. This is a top talkers. It's a group table, or we can just go down to the event table and start looking at the destination IP address and the endpoints that were communicating with it. Okay, now let's do a search, and I'm gonna delete all of the filters and go back to the subset that we're working with, to the superset. If I'm just looking for a particular IP address, let's say I put source IPv address, and I want to look for instance, 10.230.245.1, and perform the search. It will return back with all of the events where 10.230.245.1 was communicating out of the network or out of requesting information, for instance. Right, so you can see HTTP, there's a request from 10.230.245.1 to a destination IP address. So if I click on table, this is going to give me further information. I can see that the event type is HTTP. A lot of buried metadata information is in the table. What we're seeing on the event table screen at the panel itself when we start out, what we're seeing over there is just representative information. You can add columns to that by choosing more metadata so that you can see that information upfront, or you could just simply go inside the table and look at additional data that are part of this particular event. All right. Now, Let's now jump into the scenario that we were talking about, which is the hunting scenario. So the hypothesis that I have is that malware executables files have crossed my network, my local network, over HTTP in the past 24 hours. Instead of giving just the past 24 hours, which I could, I'm going to use a specific time because I know my data that I'm demoing from is within that time period. I'm going to start with the 15th of March, 9:30 p.m. And the next day will be populated with the same time, so 24 hours from that time, in that time. That's the time I'm working with, and I don't have anything at this point. I'm doing a hunting kind of scenario. I want to see all of the data that's on my network. So I will put in IPv4 address. So what is IPv4? Is that a source or destination? It's actually a OR case between the source and the destination IP addresses on that network. So if I were to give one particular IP address, if that IP address is communicating outward or if something's communicating in to that IP address, this particular metadata will allow me to see traffic on both sides. But instead of just using an IP address, I'm going to use my entire .0/4, my entire network, subnet. Okay. I know that's my local network. My hypothesis is that traffic, that executable files have crossed my local network over HTTP. Okay. So let's see what comes back. We're seeing that this HTTP traffic, indeed, SSL traffic and unknown traffic too. I want to, okay, let's just go down to the file names and see if there's any executable files. I'm not seeing any executable files. Let me look at the extensions. I'm not seeing .exe files. That's part of my hypotheses. I'm looking at .exe files. So I do know for a fact that this is all kinds of traffic, but I want to just look at file info, anything that has files that have transferred across. Okay, so I added a filter, and we're only looking at file info metadata, which means that these were actual artifacts, they were files, they were content that was transferred, and I get a number that is 2,124. The number before that was basically 19,000 records. That is too much. I need to come down. Let me see if I go back to the file names, if I see any .exe files, nothing. Anything over here? Nothing here. But I'm looking at some of these files are infrastructure files, like updates that are being performed in our infrastructure with Microsoft and other organizations. So what I'm going to do is I will put in a not case that I do not want to see those servers. And I have a list that I have defined, and you can define this list, which lists all my allowed hosts, right? And in this case, we have several. Okay. What we can do is I want to exclude this list. Right. So I can add a filter, but in this case, just to show you, I'm using it within a query rather, right? And I want to show you what I'm doing because I know that these are HTTP hosts, right? And I want to use my list allowed HTTP hosts. So I do not want to see my allowed HTTP hosts. I don't want to see traffic from that, but I want to see traffic that's coming out of my network that's communicating with other hosts other than my allowed list, right? So if I hit my search, it should reduce the number of events that are returned. So we have 600 events. That's even better. Do we see any executable files? No. I see an executable over here. Let's click on this. It adds a filter. We're looking at .exe extension. And now I can apply this. We can see this is a file suffix that was part of that panel. And if I hit apply, it takes me down to what I'm looking for. Now there's interesting information here. It's an HTTP GET event. The HTTP uses string information for that particular event. It used PowerShell. Okay, so that should raise a flag. It also communicated with a server called bad boy s something, right? So that's even. And then we have a file name. Emotet is a very well-known piece of malware. We know it's an executable. And now I want to, apart from looking at the information in here, I can see that there's an MD5 that I can investigate. There is the file name. The HTTP response means that this was successful. I have a user agent and other information. Okay. But now we want to look at what kind of malware this is. I can click on the reconstruct button after selecting the event, and this can be more than one event. If there were more than one events, if I just clicked on this, I could select all of them and reconstruct those events. I can select the event and reconstruct the artifact or the event for the artifact. This presents an additional dashboard called reconstruct and some identifying number. And by default, the first one, we're looking at the packets tab, which is similar to Wireshark. I can click on follow and it can give me a list of the events, HTTP events. This was a GET request. It shows the user agent, the host, and then the response. The response, you can see the file has been just some encrypted file information, but it was successful. So we're not going to get into that detail. You can also download the PCAP for this particular event or the full traffic associated with this event. But what I'm going to do is go to artifacts. Now, these other tabs where you have web or email, this is if you have content, like textual content in HTML, you can review that information. We're not getting into that part of this demonstration. If I click on artifacts, this is the file that we reconstructed. I can download it, save it, and perform malware analysis on it. Submit it for malware analysis, or I can submit it to our Trellix malware analysis appliance. If we do that, the response from that would be displayed in the malware analysis screen or tab on investigation analysis, and it will give you information on whether the file was malicious or not. If it was not, then we can ignore it. If it is, then you can actually go in and pivot over and look and see what exactly the results were from that. Here. So based on this, what we did today was in the demonstration, we presented a quick overview of investigation analysis. We looked at a simple hunting scenario. We were looking, but it showed you the power of investigation analysis and how you can drill down from a very large data set to what you're looking for in a very short amount of time, just based on your hunting capabilities. If you have any other interest in more information on the features of investigation analysis, or in general network traffic analysis, or in general network forensics tools that are part of the Trellix portfolio, please post in the chat what you'd be interested in, and we will try to come up with more training events like this.
Thanks, Shiraz. As a reminder for everyone, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on your screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated. What is the sizing for this packet capture?
Yes, so to answer that question, sizing is essentially done via by way of what your requirements are. So throughput is a factor that's taken into account when we're sizing the products for deployment, as well as your retention requirements with relation to the PCAPs as well as metadata retention. So the network forensics solution is a two-part solution. One is for packet captures and one is for the investigation analysis, which really is bringing in metadata from the packet capture solution. And the packet capture solution can take additional storage shelves that will add to the retention time for packet capture. And then the investigation analysis portion of the solution can be clustered. So there can be multiple of those in a cluster to increase performance and metadata storage. Your Trellix sales engineer or solutions architect can work with you to get your retention requirements and your throughput and do a calculation to size the solution appropriately for your environment.
Got it. Okay, perfect. Thank you for that one. What are the considerations when choosing a new appliance or choosing an appliance?
So that's a good related question. The primary considerations that we run into are really around retention. Again, throughput is a factor. So we have a number of different appliances and form factors that we can deploy in. So we have a number of different appliances that handle different levels of throughputs. We also have virtual appliances that you can deploy as well. But while throughput is a consideration, the primary consideration that we run into is around retention. Obviously, storing, full packet capture requires, a large amount of storage. And so Trellix has external storage shelves that are available to increase the retention time, as I said. And adding additional storage also does incrementally increase the performance of the system as far as being able to take in throughput as well. The storage that's available in the storage shelves are priced to be very competitive. So we certainly can, meet large customers' needs as far as being able to deploy and store a large amount of data.
Got it. Okay, perfect. Thank you for that one. Does network forensics just capture the packets, or will it trigger any abnormal traffic?
Okay, so I'll take that one. I know Nas did mention, did respond to that. I just will elaborate a little bit more on that. So the question is it's kind of open-ended, so I'm going to give you a little bit. First, understand that network forensics is not necessarily just the capture. The network forensics is the solution that includes both a packet capture, which was previously called PX, and then the Trellix investigation analysis tool, which is IA. IA is the analysis interface where everything comes together. So within IA, as you've seen in the demo, PX, you would have connected PX, one or more connected PX systems or packet capture systems. So the traffic that's being captured is captured on the packet capture system. And then the metadata that's coming across, that's what is being processed, and that's what is being indexed on the IA for analysis purposes or network traffic analysis. In terms of triggering abnormal traffic, So you have to look at it from which perspective. If you are looking at it from the incident response perspective, then I assume you're asking whether you would receive alerts for that and what will generate those alerts. When integrated with network security, which used to be called NX, network security alerts, when integrated with investigation analysis, will appear in the web UI as an alert, and then you can follow up to the specific flow and investigate that flow locally. If a rule has been defined on the packet capture system, you can define Suricata rules there, and if that rule is triggered, then indeed you will see that alert as well. You would be alerted on that. If, for instance, you are a malware object is written, for instance, and it's integrated with endpoint security, which is also known as HX, Trellix Endpoint Security, you would see a malware object alert, and then again follow up or pivot to that system. So that's the incident response aspect of it. But if you're talking about, of course, hunting would be a proactive instance where you are that's where your skills are going to come into place, coupled with the investigation analysis interface. So a few very well written queries start off wide and then narrow down until you find what you're looking for, coupled with the dashboards that include well-written panels, will help you find, drill down, as I've demonstrated in the demo, very quickly to suspicious traffic and suspicious artifacts. And then again, those can be submitted to malware analysis, or you could just perform your own analysis on any artifacts that may occur. Looking at abnormal traffic, you certainly can create histograms. And again, it's just how you build your panels. It's going to depend a lot on your hunting skills. Hope I've answered that question.
Got it. Okay, perfect. Thank you for that one. It looks like we got to most of the questions. We have a few that are a bit more specific. What we'll do is we'll work to collect those questions and follow up with you folks after the webinar. I want to thank everyone for joining today's webinar, and a big thank you to our presenters, Shiraz and Nasir. As a reminder, a link to today's recorded presentation will be emailed to all registered attendees. This concludes today's webinar. Stay safe, everyone.
Thank you.